Right, so there are going to be a couple of formulas that we're going to come across in chapter 4, and particularly in this 4.1, and these two are going to be among two of them. By the arc length formula, so this is the same formula that you have seen at the beginning. So the fact that theta is actually S over R. So if I were to rearrange this, I will get that S is going to be theta multiplied by R. So which is this formula right here, or S is equal R theta and so on. And as I mentioned before, what is going to be S? S is going to be the length of the arc. So this is going to be our S. And what is going to be R? R is going to be the radian, and theta is going to be the angle. So that's going to be all the components, right? And then another formula that you're going to come across is going to be sector area formula. So instead of like just finding what is going to be the distance of the length, okay, so distance of the arc, which is called as the arc length, so we can also find the area of the area that is between the two lines. So here this is our two lines, so the area that is confined between both of the lines, so we can also find by using this sector area formula. And the formula is given by the area is going to equal a half of r square theta again. So if we know what is going to be the value of r and what is going to be the value of theta, automatically you can find both the arc length, and you can also find the area confined by the two lines. So I'm going to start with this example here. So here what I'm going to do for one is I'm going to find the arc length S in the following figure. So first of all, so please make sure that your angle is in terms of radian unit, and of course, so 4 pi over 5, so there is no degree right there, automatically that is going to be in terms of radian unit. So let me put A over here. So the two information that we have is R is going to equal 3 meters, and theta is going to equal 4 pi over 5. So therefore, I'm going to calculate RS is going to equal R theta, and that is given by 3. So multiplied by 4 pi over 5. So you know what? I know that you are tempted to press your calculator and give the answer in terms of decimal point. For example, it's going to be 12.5. It's going to be 2 point something. No, please don't bother doing that. I don't want the answer to be in decimal place. So usually for cases like this, so leave pi aside. So just press your calculator for the rest of them. So which is 3 multiplied by 4 over pi over 5. So this for this case is going to be 12 over 5 pi. So this is going to be a better way of writing your value instead of all the decimal places. So for this case, it's going to be 3 multiplied by 4 pi over 5. I get 12 over 5 pi. And of course, so what is S? S is the length. And what is going to be the unit for this case? Because R is in terms of meters, automatically this is also going to be in terms of meters. So it's going to be 12 over 5 pi meters. So this is going to be in terms of meters. So that is going to be for example number 1. So that is not A, this is example number 1. Okay, example number 2. So it's going to be the same idea. So we're going to find the length of an arc of a circle with radius 10 meters. So that is the first information that we have, which is radius is going to equal 10 meters. That subtends a central angle of 30 degree. So here, so the second information is that theta is going to equal 30 degree. However, as I mentioned to you before, so when your theta is not in term of radian, so change it first to be in term of radian. Okay, so how do I change it in term of radian? So I'm going to have to multiply this by pi over 180 degree. Here I can simplify this. This is going to be 1, this is going to be 6. So basically 30 degree is equivalent to pi over 6 radian. So knowing that this is going to be pi over 6 radian, so now we can start finding. So what is going to be the value for the arc length? Hold on. Okay, so now I'm going to start using the formula. So I'm going to write that S is going to equal R theta. And for this case, our R value is equal 10 and the unit is meters. And I multiply that by theta, which is equal pi over 6. So therefore, when I simplify this, I will get 5 pi over 3. and that is going to be in terms of meters. So that is going to be the arc length. So first, make sure that you have r and theta if you want to calculate the arc length, and the theta has to be in terms of radian. Okay, this is going to be example, but this is going to concern about the second formula, which is going to be area of the so it's going to be area, what formula is that? What is it called? Sector area formula. That's right, that is called as a sector. So it says find the area of a sector of a circle with central angle pi over 3 radian. So that is going to be our theta. So our theta is going to be given by pi over 3 radian. And put over here, so this is theta. If the radius of the circle is 3 meters, so that is going to be our radius. So radius is going to equal 3. So now we're going to apply the formula. So A is going to equal half r squared theta, and now we have to do substitute, which for this case is going to be half multiplied by r, which is going to equal 3 square, so multiplied by theta, which is going to equal pi over 3. And if I were to simplify this, I think I will end up with 3 pi over 2. So this and this, they're going to cancel. So that is how I end up by 3 pi over 2. Okay, and for this case, this is going to be area. So remember, because radius is in terms of meter, so when we multiply r square, so that's going to be meter multiplied by meter. So of course, for this case, our unit is going to be meter square. So therefore, for this case, the area of the sector is 3 pi over 2 meter square. Okay, number 2. So it says over here from the figure, so where we're given a figure. So what information do we have from the figure? The first information is that the radius is going to be given by 3 meters, and that the theta, so the value is going to equal 135 degrees. So those are our two informations. So what we're going to do is first we're going to find the parameter of the sector. What is the parameter? So parameter is going to be, what do you call that? It's going to be the length of the whole. In Malay it's called as ukur keliling, the whole surrounding. So what is going to be the length of that? For example here, so what is going to be the parameter? It's going to be the whole thing over here. So this is going to be called as being the parameter. And for this case, so I already know that this side is going to equal 3 meters, and this side, because it's the radius as well, so that is also going to equal 3 meters. So now we need to find what is going to be the arc length. So if we have the arc length, so we're going to add them up together, and then we will get the value of the parameter for the sector. Okay, but first of all, notice that the unit of the theta is in terms of degree. So I'm going to have theta is going to equal 135 degree. So converting this to radian, I have to multiply this by pi over 180 degree. And if you use your calculator for that, so you will get that the value is going to equal 3 pi over 4 radian. So when you use your calculator, simply put 135 over 180. So that is going to give you 3 over 4, and simply multiply that by pi. So just leave pi aside, but remember to put together for the answer. Okay, so now that we have this, so I'm going to use the formula. So the S is going to equal r theta, and r is equal 3 for this case. So I'm going to have 3, so multiply by 3 pi over 4. So that is going to equal 9 pi over 4. So the arc length is going to equal 9 pi over 4. But remember, so for this case, we don't want only the arc length, but we want the perimeter. So then put over here. So the perimeter is going to equal, so we have 2 radiuses over here. So 3 and 3. So then put over here. So I'm going to have 3 plus 3 plus 9 pi over 4. So that is going to equal 6 plus 9 pi over 4. So either you leave it like this, or you can actually make it into only one fraction. So I'm going to have, this is going to equal 24 plus 9 pi over 4. But if you leave it in this form, so that is actually good enough. So no need to make it in terms of the simplified fraction. So just leave it like that. So it's going to be easier that way. So meaning for this case, our parameter is going to equal 6 plus 9 pi over 4. So that will be for A. So now let's have a look at B. So what does B wants? For question B, so it says it wants the area of the sector. So now we have all the informations already. So we can just simply put the formula. So A is going to equal a half r squared theta. So that is going to equal a half multiplied by 3 squared, because r is equal to 3. And our theta for this case is equal 135 degrees. So which converted to 3 pi over 4 radian. And if you use your calculator for this, a half multiplied by 3 square multiplied by 3 multiplied by 4. So that is going to simplify your calculation to what value? I'm going to have 27 over 8 actually. So this is going to equal, so 27 over 8 pi. And what is going to be the unit? Because r is given in term of meter, so this is going to be meter square unit. That is going to be in terms of the example. And of course, I have prepared a couple of exercises for you to try. So how to convert the angle. So I've given you like sentence problem for you to try, and with the solution as well. So given